In this lesson, we're going to use some ratios that we've already talked about, and we're going to go on and talk about a concept called proportion. And when two pairs of numbers, such as 2 and 3 and 6 and 4, have the same ratio, we say that they are proportional. So we can write a statement that says 3 is to 2 as 6 is to 4. 3 halves is the same as 6 fourths. We call it, when we have one ratio equals one ratio, we call it a proportion. All right, we're going to, in this section, determine whether the ratios are the same. In other words, are the two sets of numbers proportional? There's two examples from your book. Determine whether 1, 2 and 3, 6 are proportional. You can use cross products, and we really have done this before. We did it back when we were working with fractions. We just weren't calling them ratios, and we weren't calling the statements proportions. If you look at the cross product, 6 times 1 or 1 times 6 is 6, and you look at this cross product, 2 times 3 is 6. If the cross products are the same, then the numbers are proportional. The ratios are proportional. Here's another example. 2 is to 5 as 4 is to 7. Is that true? Well, let's see. Let's look at 7 times 2 is 14, but 5 times 4 is 20. So this is no, they are not proportional. Well, this one was yes. So if the cross products are equal, yes, they are proportional. If the cross products are not equal, then it is no. So let's look at some. It says 17 and 10. Is that proportional to, so it's a question mark right now, 13 and 9. All right, let's see. Doesn't matter which one you do first, but you have to look at the cross products. One of them is 17 times 9, which is 63. Carry the 6. That's 153 for this cross product. This cross product I can do in my head. 10 times 13 is 130. Those cross products are not the same, so this one is no. They are not proportional. Determine whether these are proportional. All right, let's see. 6 is to 8 as 60 is to 80. This is a question mark right now. Multiply 80 times 6, 480. 8 times 60, 480. The cross products are equal, so this is yes. Let's look at another one. It has 0.8 or 0.8 is to 3.6 as 0.6 is to 2.7. So are these pairs of numbers, are these ratios proportional? Well, let's see. One of the cross products is 2.7, 0.8. 8 times 7 is 56. Carry the 5. 8 times 2 is 16, and 5 makes 21. 2 decimal places. So it is 2.16. Let's look at that was this cross product. Let's look at this cross product. 3.6 times 0.6. 6 times 6 is 36. Carry the 3. 6 times 3 is 18, and that's 21. 2 decimal places, 2.16. The two cross products are both 2.16. So yes, these are proportional. This next one's going to take a little bit more space and work. Did I skip one? No? All right, let's look at this one. It says, are 5 1/5 to 9 1/3, is that the same as 1/3? 6 1/5 to 3 1/4. All right. I need to look at this cross product and this cross product. All right, one of the cross products, this one, 5 1/5 times 3 1/4. To multiply mixed numbers, I need them to be improper. 5 times 5 is 25, plus 1 is 26/5, times 4 times 3 is 12, plus 1 is 13/4. Can I do a little bit of reducing? And the answer is yes. 4 is even, 2 goes in there 2 times, 26 is even. 2 goes in there 13 times. Multiply the tops, 13 times 13 is 169. Multiply the bottoms, 2 times 5 is 10. That's the first cross product. Let's look at the second cross product. I have 9 1/3 times 6 1/5. Make them improper. 3 times 9 is 27, plus 1 is 28/3, times 5 times 6 is 30, plus 1 is 31/5. Try to reduce anything. I don't think I can. So when I multiply the tops, let me see, that's 28 times 31. It's 28. Placeholder 0. 3 times 8 is 24. Carry the 2. That's 6. That's 8. That's 868. The numerator is 868. The denominator is 15. And these are not the same. So the answer is no. So I did have to do multiplication with mixed numbers, changing them into improper fractions, but nevertheless, I was still looking at cross products. If the cross products are equal, the two ratios are proportional. Now it's your turn.